Welcome. Today's topic is about an introduction to pattern recognition. Pattern recognition is a process of distinguishing and segmenting a data according to some set criteria by some common features, which is performed by some special algorithms. Data segmentation is taking the data we hold and divide it into groups of similar objects. It deals with automatic discovery of regularities in data through the use of some computer algorithms to divide the data into categories. The data itself can be anything. It may be a text, image, sound, sentiment, or anything. Pattern recognition, some definitions. It's formally defined as the process whereby a received pattern or signal is assigned to one of the prescribed number of classes. A pattern could be an object or an event. So in these examples, we could see fingerprint pattern, iris pattern, face recognition, hand recognition, disease classification, etc. Hand gesture pattern recognition is based on the changes in the hand direction, some actions needs to be performed. The classification is defined as the process whereby a received pattern or signal is assigned to one of the prescribed number of classes. Classification may be either supervised or unsupervised, or one more, reinforcement learning. Supervised learning is we have the labels for the data. So in this data we have category A data or category B data. Unsupervised learning is we divide the data into categories like similar kinds of ones are made as one class and the other kinds of ones as another class. So this one we don't have a labels. Why do we need pattern recognition? Human beings can recognize things and objects based on their past experience, but to make the computers learn it, we need to give thousands of data, make it learn with it. So when we give such images, the system can learn it as rocks, trees, people, beach, etc. And when a new image data is given, it can easily classify. And this example is about an animal classification. So it segments the shape of the animal based on the shape, size, texture, tail size, ears, etc. of the animal. It can identify the animal. The pattern recognition techniques are classified as statistical, syntactic or structural, and template matching. Statistical is to identify where the specific piece belongs to. Example, whether if a data is a cake or not a cake. It may be an animal, a bird, a nature, anything. This is a supervised kind of learning where we have labels for the data. Syntactic or structural data is to define a more complex relationship between elements. It uses semi-supervised machine learning model. Template matching is to match the object's features with a prescribed template and identify the object by proxy. So one of the use of such a model is plagiarism checking. So we have the data and we have a whole lot of content in the Google. In all, both the data and the whole remaining content are matched to get the amount of percentage of similarity in the data. So pattern recognition techniques may be template matching. The representations are maybe samples, pixels in image, curves, etc. Correlation distance measure is used, and classification error is the performance measure. Statistical features are used, discriminant function and classification error. For neural network, samples, pixels, features, network function, and the acceptance error. Syntactic structural, primitives, rules and grammar, and mean square error. So what is a class? A class is a group of similar objects. So female class and male class. Pattern classification system. The single data, maybe image or text or video or whatever, the data is given to a pre-processing system to clean the data, remove some unwanted error and noise in the data, and then we do feature extraction to extract the necessary features about the data and then give it to a classifier to identify the class or pattern in the data. So in statistical pattern recognition, we model the variations of features values through probability distributions. So pre-processing, feature extraction and classification are the work. Examples of pattern recognition tasks are reading facial expressions, recognizing speech, reading a document, identifying a person by fingerprint, diagnosed from medical images, etc. Example loan applications. The two classes may be approve the loan or don't approve the loan. The features are income. If the income is high, approve the loan. Dependents, how many number of dependents are there, any loan already taken. So such history will help in identifying whether a loan can be given to a person or not. Character recognition, in this case we have 26 classes A to Z. A can be written in differently by different persons, similarly other words too. The features for this example are binary image, projection, moments, etc. Biometric identification, to class whether this is a person or not a person, and these are the features. Sorting in fishes as sea bass or salmon. So the features may be like length, lightness, width, etc. of the fish image. So design of a pattern recognition system. Features depends on the problem. So after feature extraction, the pattern is a vector. Classifier is a function to map such vector into class labels. Need to test and validate the final system. So the feature space Rn, X is the set of all possible feature vector. So classifier function is a decision rule or a function map the feature space. H of X is from 1 to M. M is the number of classes and M may be a multi-class problem. M is equal to 2, the labels are 0 and 1 or minus 1 and 1, then it is a binary 2-class problem. So how to choose the H value, correct optimal classifier, how to choose, how to design the classifier, judge the performance, etc. are the work of a classification problem. So first we'll consider a two-case problem. So M is equal to 2. So some alternative design M2 classifier, 1 versus rest. It may be a cake or anything else. Other possibilities of designing a multi-classifier is a tree structure. The two-class problem is a basic option. A simple pattern recognition problem. Spot the right candidate in the interview. So the features may be X1 is marks from the academic record and X2 is marks in the interview. We may write equations in different forms based on our requirements. Some examples are Ax1 plus Bx2 is greater than some threshold value C. Then the candidate can be chosen. X1, X2 is greater than C. X1 plus A into X2 plus B is greater than C. Any such equations can be modeled for our problem in hand as per our requirement. Design of classifier. We have to choose special form of a classifier. What values to use for parameters such as A, B and C. These are the weight values and the threshold value. So need to decide how the feature vector values determine the class. The difficulties are lots of variability in the patterns of a single class may be there, noise may be there. So simple pattern recognition problem. So for designing a classifier, we need to identify X1 and X2 features are plotted as a scatter plot, and we need to identify this dividing line which best fits the data. Many classify algorithms to supervised learning where we have the labels. So Xi and Yi are the data. Xi is the data and Yi is the label. Predict the time for general system identification. Training set. We have X1, Y1 up to XL, YL. Essentially we want a best fit line. So this may be the best fit line which divides the stars and the circle. And suppose X belongs to the feature vector and this is a familiar curve fitting problem. Learning from examples. To obtain the classifier we use the training set. We have the whole data. We divide the data into training data, test data and validate data. Training data is to train the data, train the model or algorithm model with the data in hand. Then we test it with the remaining data to find the accuracy of the classification model. Statistical pattern recognition. Let X be the feature space which belongs to the feature space Rn, and Fi is the class, F0 is class 0 and F1 is class 1. So let X1 equal to X1, X represents the feature vector. So for a binary class problem, let Qi is the probability that class I equal to 0, 1, 1. Qi is called posterior probability for class I. So this is about the introduction for classification. Thank you.